B.A Geography, Semester 6, Geographic Information System, GIS, Data Types in GIS. Objectives. In this chapter, we will understand about the following: data types, spatial data, attribute data. Spatial data types: raster data, vector data, image data. Raster and vector advantages and disadvantages. Data types. The basic data types in GIS reflect traditional data found on a map. Physical entities or phenomena are approximated by data in a GIS. These data includes information on the spatial location and extent of the physical. Accordingly, GIS technology utilizes two basic types of data. These are spatial data and attribute data. Spatial data. Spatial data describes the absolute and relative location of geographic features. Spatial features may be discrete or continuous. A GIS can represent spatial data which has a physical dimension on Earth. The various components of geographic data can be reduced to the form of point, arc or a polygon for effective processing. In a case of a GIS, the data may be available in a tabular form, a geographical map, a digital map or a remotely sensed map. Discrete features are those that do not exist between observations from separate entities and are individually distinguishable. Wells, roads, buildings and land use types are examples of discrete features. Continuous features exist especially between observations. Precipitation of rain and elevations are examples of continuous features. Attribute data describes the characteristics of the spatial features. It holds the characteristics of the spatial features and the descriptive information about the geographic features. These characteristics can be quantitative and qualitative in nature. Attribute data are non-spatial data associated with time and area entities. Attribute data is often referred to as a tabular data. The GIS attributes are represented using colors, textures and linear or graphic symbols. For instance, school, college locations are designated using special symbols and contour lines with brown color. The actual value of the attribute that is measured or sampled and stored in the database is called attribute value. Also, each spatial entity may have more than one attribute associated with it. For example, a point representing a hotel can have a number of rooms, different standard of accommodation, different parking space, etc. The amount of attribute data to be attached to a spatial feature varies significantly depending upon the feature type and the application. The other data types, in particular image and multimedia data, are becoming more prevalent with changing technology. Depending on the specific content of the data, image data may be considered either spatial, for example, photograph, animation, movies, or attribute, for example, sound, description and narration. Attributes may be classified into two: primary attributes and secondary attributes. Socio-economic characteristics and physical properties of an object are some of the examples of primary attributes, while flow of information levels, districts, capital and names of constituencies are secondary attributes. Spatial data types. Traditionally, spatial data has been stored and presented in the form of a map. Figure reflects the two primary spatial data encoding techniques. These are vector and raster. Image data utilizes techniques very similar to raster. However, typically it lacks the internal format required for analysis and modeling of the data. Images reflect pictures or photographs of a landscape. All spatial data models are approaches for storing the spatial location of geographical features in a database. Vector storage implies the use of vectors, directional lines, to represent a geographic feature. Vector data is characterized by the use of sequential points or vertices to define a linear segment. Each vertex consists of an x coordinate and y coordinate. Vector lines are often referred to as arcs and consist of a string of vertices terminated by a node. A node is defined as a vertex that starts or ends an arc segment. One coordinate pair and a vertex define a point feature. Polygon features are defined by a set of closed coordinate pairs. In vector representation, the storage of vertices for each feature is important, as well as the connectivity between the features. For example, the sharing of common vertices where features connect. The geometry of a point is given by two-dimensional coordinates x and y, while line, string and area are given by a series of point coordinates as shown in the figure. You can observe how there is a difference between the line and the point. Whenever there is an open one, we are going with a point and line and a string, or else whenever we want to represent a closed area, then we would go for an area or a polygon vertex. Raster data. Raster data incorporate the use of grid cell data structure, where the geographic area is divided into cells identified by rows and columns. This data structure is commonly called raster. While the term raster implies a regularly spaced grid, other tessellated data structures do exist in grid-based GIS system. A raster data structure is in fact a matrix where any coordinate can be quickly calculated if the origin point and the size of the grid cell is known. Since grid cells can be handled as two-dimensional arrays in a computer encoding, many analytical operations are easy to program. This makes tessellated data structure a popular choice for many GIS software. Topology is not a relevant concept with tessellated structure, since adjacency and connectivity are implicit in the location of a particular cell in data matrix. The geometry of raster data is given by point, line and area objects as follows. Point objects. A point is given by point ID, coordinates and the attributes. Line object. A line is given by a line ID, a series of coordinates forming the line and the attributes. Area object. An area subsegment is given by an area ID, a group of coordinates forming the area and the attributes. Area objects in raster model are typically given by run length that rearranges the raster into the sequence of length or number of pixels of each class as shown in the figure. The topology of a raster model is rather simple as compared with the vector model. The topology of the line objects is given by a sequence of pixels forming the line segment. Several tessellated data structures exist. However, only two are commonly used in geographic information system. The most popular cell structure is regularly spaced matrix or raster structure. This data structure involves a division of spatial data into regularly spaced cell. Each cell is of the same shape and size. Squares mostly commonly utilized. Besides, since most data is captured in a vector format, for example, digitizing data must be converted to raster data structure. This is called vector raster conversion. Most GIS software allows the user to define the raster grid cell size for the vector raster conversion. it is imperative that the original scale, for example accuracy of the data, be known prior to conversion. The accuracy of the data, often referred to the resolution, should be determined the cell size of the output raster map. During conversion, it is also important to understand that the selection of a particular data structure can provide advantages during the analysis stage. For example, the vector data model does not handle continuous data, for example elevation, very well, while the raster data model is more ideally suited for this type of analysis. Accordingly, the raster structure does not handle linear data analysis, for example shortest path, very well, while raster vector system do. It is important for the user to understand that there are certain advantages and disadvantages to each data model. Image data. Image data is most often used to represent graphic or pictorial data. The term image inherently reflects a geographic representation, and in the GIS world it differs significantly from raster data. Most often image data is used to store remotely sensed imagery, for example satellite scenes or orthophotos, or ancillary graphics such as photographs and scanned plan documents. Image data is typically used in GIS system as background display data if the image has been rectified and georeferenced, or as a graphic attribute. Remote sensing software makes use of the image data for image clarification and processing. Typically, this data must be converted into a raster format and perhaps vector to be used analytically with the GIS. Vector and raster advantages and disadvantages. There are several advantages and disadvantages for using either vector or raster data model to store spatial data. They are summarized. Advantages of vector data. The data can be represented in the original resolution and form without generalization. Graphic output is usually more artistically pleasing, traditional cartograph representation. Since most data, example hard copy maps, is in the vector form, no data conversion is required. Accurate graphic location of data is maintained. It allows for efficient encoding of topology and as a result more efficient operations that require topological information, for example proximity network analysis. Disadvantages of vector data. Each vertex need to be stored extensively. For effective analysis, vector data must be converted into topological structure. This requires intensive processing and extensive data cleaning. Also, topology is static and any update or editing of the vector data requires rebuilding of the topology. Algorithms for manipulative and analysis function are complex and may be required for intensive processing. Often, this inherently limits the functionality for large data sets, for example, a large number of features. Continuous data such as elevation data is not effectively represented in vector form. Usually, substantial data generalization or interpolation is required for these data layers. Spatial analysis and filtering within polygons are impossible. Advantages of raster data. The geographic location of each cell is implied by its position in the cell matrix. Accordingly, other than an origin point, example the bottom left of the corner, no geographic coordinates are stored. Due to the nature of the data storage technique, data analysis is usually easy to program and quick to perform. The inherent nature of raster maps, example one attribute map, is ideally suited for mathematical modeling and quantitative analysis. Discrete data, for example forestry stands, is accommodated equally well as continuous data, for example elevation data and facilities that integrating the two data types. grid cell systems are very compatible with raster based output devices. For example, electrostatic plotters and graphic terminals. Disadvantages of raster data. The cell size determines the resolution at which the data is represented. It is especially difficult to adequately represent the linear features depending on the cell resolution. Accordingly, the network linkages are difficult to establish. Processing of associated attribute data may be cumbersome if a large amount of data exists. Raster map inherently reflect only one attribute or characteristic for an area. Since most input data is in vector form, data must undergo vector to raster conversion. Besides increased processing requirements, this may introduce data integrity concerns due to generalization and choice of inappropriate cell size. Most output maps from grid cell system do not conform to high quality cartographic needs. It is often difficult to compare or rate GIS software that uses different data models. Some personal computer packages utilizes vector structure for data input, editing and display, but convert to raster structure for any analysis. Other more comprehensive GIS offerings provide both integrated raster and vector analysis techniques. They allow users to select the data structure appropriate for analysis requirement. Integrated raster and vector processing capabilities are most desirable and provide the greatest flexibility for data manipulation and analysis. Summary. The main objective of a GIS is to reduce the time for expensive activities of handling, recording, researching, handling of huge amount of data and generating and establishing its relation to the geographical position or land feature. The rapidly decreasing cost of computer hardware and software make the GIS handle more tasks, thus making it the wider audience. Also, the cost of data storage devices in a computer has decreased drastically in recent years, and the computer memory has increased from kilobytes to gigabytes. The primary goal of a GIS is to take a raw data and transform it by overlapping and by various analytical calculation into new information that can help make a sudden decision. A GIS is not built for one or two specific application, but it is a common problem solving tool. A GIS provides an organization with capability of applying geographic analyst methods to designated geographic areas to solve various problems. There are few reasons why GIS is needed. Geospatial data are poorly maintained. Maps and statistics are outdated. Data and information are inaccurate. There is no data retrieval service. There is no data sharing. Once a GIS is implemented, the following benefits are expected. Once a GIS is implemented, the benefits are expected. Geospatial data are better maintained in a standard format. Revision and updating are easier. Geospatial data and information are easier to search, analyze and represent. More value added products are obtained. Geospatial data can be shared and exchanged freely. Productivity of the staff is improved with more efficiency. Time and money are saved. Better decisions can be made within a short time.